Hello, everyone.
Good morning, everyone.
Good morning. Good morning.
Hope you're all doing fine. So this is Rahul. So I'll be from today. I'll be taking up the CCNA from network for networkings. So yeah, before we start off, just want to uh, just give a brief introduction about myself. So I've been in the industry like for 14 years, right? So from the starting of my career, I've been working in a telecommunication sector. So it is kind of it involves like kind of companies like Verizon, AT&T, and last but not least, Accenture. So it all involves telecommunication. Luckily, I was a part of all the service provider and CCNA, CCNT routing and switching domain throughout, and also which includes a part of security. So, how many of you here have already done CCNA or like trying to revise?
And not done, this is first time. Hi, this is Virendra Singh. I don't have
Hey,
any experience.
Brandon. Okay,
Like,
so this is your okay. Anybody from a network background? Follow you.
Yeah, hi. My name is Sanjeev. So I'm working as a network engineer.
Awesome, Sandeep. So you should be. Do you deal with network and stuff on a day-to-day basis?
Yes, I do. Yeah.
So you're aware of CCNA and all that.
Yeah. Yeah. I know how it works. Yeah.
Mhm. So you've done the course as well before?
Yeah. Long before, so I just want to brush up. So yeah, that's why.
Gotcha. That's nice. Shankar wants to say anything? All right. Anyways, let me go ahead and share my screen before that.
Hello,
Is
Yeah.
this the demo class or?
sir. I'm audible to you.
Yeah, you're audible to me. This is the first class of CCNA. First class in the sense, this is the first class where we're starting off with the syllabus.
Okay.
All right. Let me know once you guys are able to see my screen. Able to see my screen?
yes, your screen is visible
Yeah.
nicely.
All right. So just as an introduction, these are the topics that we're gonna cover. Okay. So I'm not sure if you guys have gone through the topics or if you have not gone through the topics, or maybe there is also a probability that you don't know what topics are in CCNA syllabus also. There might be a case with one or two like that as well. Maybe somebody would have guided you, go with CCNA, maybe you've joined that course, right? That is also possible. So before starting off, let me actually tell you, CCNA is actually the fundamentals. I mean, you're unable to hear anything. Abhishek is actually telling me he's unable. Guys, you're able to hear me?
Yes.
Yeah,
Yes.
we can hear.
Abhishek is not able to hear. I think Abhishek, everybody are able to hear me. So I think it's a problem. Might be one of your headphones or something is bad. Okay, moving on. So it is kind of basics that we have to learn while we are trying into, trying our step into the networking field, right? So basically, what we need to do in CCNA is we have to learn how the devices communicate with each other. Like, so we are normal people, right? We have a language to talk to each other, right? In the same way, there should be something for computers, routers, switches, or whatever networking devices they are, servers, right? Clients. They have to have some language to speak to each other, the communication, right? That is nothing but your networking. Okay. CCNA stands for Cisco Certified Network. So if the very beginning expansion, Cisco Certified, tells you that all the devices used in this particular domain is Cisco devices, are Cisco devices, right? Because it is a Cisco certified. Cisco is conducting this exam, Cisco is making this syllabus. So all the devices that are used for lab or for explanation could be the Cisco devices, not could be, it is Cisco devices, right? Now, starting off, I have few topics. Just introduction, like what are the network devices and so. So basically, before starting off with the teaching, right, I can proceed with the syllabus. I can immediately start off with the syllabus, but I just want to know if people, when I say, for example, I'm telling you, say, hub is a thing which actually it's a layer one device. It is no intelligence, it does not have any intelligence. It just broadcasts everywhere. But people should understand what is a broadcast now. If he says that what is a broadcast, he has to understand, okay, this is how the broadcast happens. And also if I say, uh, switch is an intelligent device, it takes down the writing of a MAC address from the receiver port to the you know sender port. They should understand, like, have you guys seen a switch or a hub any time before, or do you know the functioning of a hub or a switch? Is there anybody who doesn't know?
I've seen switch and routers.
Okay, do you know the functioning of it? How it functions and what does it do and all that?
Routers are used for routing, and switches are mainly used for LAN network.
Okay. So is there anybody who does not know anything, who are starting as a very fresh candidate for this CCNA? Just want to know, because the explanation should be in the basic terms if somebody doesn't know about it, right? I cannot go over it, so just wanted to make sure. Now, whenever you take a field, like you take about software, you take about hardware, okay? You take about wireless. There should be some devices, right? Which supports wireless, hardware, software. For example, what are the things that you know in software which support software? Coding, right? The most famous, most popular coding. For that, you need a server client, right? Wireless. For wireless, what do you need? Wi-Fi, access points. Similarly, for networking, you need networking devices. What are those networking devices? Hubs, switches, right? Routers, firewalls, right? These are the devices which actually make up your network. Whenever you speak about a network, you should know that the network devices are hubs, routers, switches, and so on. Because I'm just not making you by heart it. So, because as and when we deal with different, devices in future, you will get to know that okay, these are the devices because these are the devices I play with on a regular basis, right? So, let's talk about the first device. We can talk about the first device, but before that, anybody has any confusions, or we move further? Anybody has any doubts?
So far,
Okay,
good.
I will take that as none, and we'll start moving. Hubs. Now, during yeah, Abhishek, do you want to say something? Rinkesh is saying that voice is not audible. Okay. I think everybody else are able to hear. Just try reconnecting to the meeting, Rinkesh. All right, moving on. First, let's take, I'll just, you know, give me a minute here. Rinkesh, one minute, guys, I'll be back. All right, I'm back. Okay, so let's take an example. Okay, not an example. Now, first of all, whenever there was a computer invented, okay, there was a computer invented, right? Now, whoever invented this computer was able to do all the Excel calculations, whatever. Okay, he was able to do a list of objects, right? He was able to list out everything. Fine, he should be good with that. But he was also playing some games, whatever. Then he had lots of data in his computer, lots of data, right? Now, everything was going smooth until unless he found out that, okay, this is my house. Until I come to this computer, I don't have access to that data which I have stored in this computer anywhere outside. If he goes anywhere outside his house, he is not able to access that particular data or whatever the list of Excel files that he has stored in this computer anywhere outside this his house, right? So there arose a problem. What is the problem? Communication. So what he did, so okay, I'll keep another computer for office because I am not able to access this particular data in my office. So I'll take another computer in office. What he did, again he made all the data, replicated it, okay, on the computer in his office. The same Excel list, everything is he prepared. Next, he moved to his branch site or many branch offices or whatever. He moved to another location, but he is not able to get hold of either of the data, right? Maybe you can also imagine it as room, hall, maybe room number 2. When he goes from one room to the other, he is not able to get that same particular data on 3 different PCs. But he has 3 different PCs. Again, he has to write all the information from PC1 to PC2 if he wants to access. That is where there arose the need of something which is centralized. Even though you have 2, 3, or 4 PCs, a person realized, okay, the one who discovered realized that there is a need for connecting from one system to the other, right? There is a need for connecting one system to the other. Why? Because if I have computer and do not connect it to internet or do not connect it to anybody across, let's say I have a computer and I don't connect to anybody of you, I just have it at home, I don't connect to the internet, nothing. What am I doing? Nothing. No use of that computer which is only to me, unless and until I get the information from outside or send the information outside, neither talk with people. That kind of a computer is not at all useful. So they found out connecting from one computer to another computer is very important. So they brought cables. They started connecting from one computer to the other. In early old days, you knew the computers were very less. Just when the computers were discovered, you could see that only in 1 or 2 houses, or maybe in 1 in 10 houses, not in 10, 1 in 100 houses had computers, right? So at that time, computers were very less. So if there was any computer anywhere else, they said, okay, I'll ask service provider. Now, what are the service providers in India or like US? Like in India, we have something known as, Airtel, Vodafone, or Jio, Reliance, whatever it is. In US, we have Verizon, AT&T. These are the service providers which actually connect from one organization to the other, or connect from an organization to the internet. Okay. Now we connected from one computer to the other. Okay. I brought a computer at home. Okay. It's in room 1. I brought another computer, which is in room 2, just to share the information between them. I wanted to share the information between them. I connected from room 1 to room 2 using cable. Now, I brought another computer, which is in room 3. Even that needed the information. I took another cable. Next house, I wanted to connect to the next house, who is a friend of mine. I took another cable. And he has 2 computers. I connected with another cable. So as you can see, the usage of cables are increasing, where the cables are costly, right? The usage of cables were increasing as and when the computers were increasing, right? As and when the computers were increasing, the usage of cables were increasing. So what they did, they came up with an idea. All right, let's discover something known as a centralized device. What is the centralized device? It is a centralized point where you can connect all your computers to. They got a hub that they named it as a hub. Okay. Now bring in your computer. First floor, connect it to this. Second floor, just connect it to this. Third floor, just connect it to this. Fourth floor, connect it to this. Okay. Now also you're using cables, but just to connect to the hub. Okay. And the hub, as you can see, if you want to connect from PC1 to PC2, you're using one cable. PC1 to PC2, another. PC1 to PC3, another cable. You see how many cables you were using per PC. It was more, right? But with hub, just use one cable, finish it off. Hub was known as centralized device. Why centralized device? If I send the information out of here, it will send to all of them except myself back. Okay. Only on the port which I have sent, it will not come back. But the information will go to all the other ports. Okay. That was how the hub was designed. That was a intelligent design, right? Now, moving on. Till now, anybody has any doubts? Are we good?
Yeah. Thanks.
Okay. Moving on. Hub was able to do the job of a centralized device. Fine. You don't have to send to each computer. You don't have to send to each computer. Okay. You just send it to me. You just send it to me. I am a centralized device. I will take care of forwarding the traffic to I'll send out the traffic to all the other. Fine. That was working fine. That was an intelligent move. Okay. But you know the functioning of a hub. If I send it out on one port, it will automatically send the same traffic on all other ports. On all other ports. On all the computers connected to all other ports. All right. So what if you send it from here? If you send it from here, except this port where the information is coming in, it will send the same information on all other ports. Even if there is a port here, it will send the information on that port. So what do we call that? There are three types of communication. Communication is divided into three types: unicast, broadcast, multicast. Right? What is a unicast? One person talking to one other person. For example, this computer talking to this computer. One person, one sender, one receiver is known as unicast. Whereas, let me write as one-to-one. One sender, all are receivers. Like in our hub, right? In our hub, I just showed you, if you send out the traffic on one port, all the other ports will have that information received. Okay? All the other ports will get that information. So it is one to all. Let's talk about multicast. One to group. One to group. Now what is a group? One to all. One to group. Okay. Now what is a group? For example, only this computer, these two computers wants to receive the traffic which is sent by PC1. PC3, PC4 only wants to receive. PC2 doesn't want. So it's only a group of receivers, one to a group. One sender to one receiver is known as unicast communication. One sender to all receivers, one sender to all is known as broadcast. One sender to a group of receivers is known as multicast. For example, the training which I am doing now is a multicast. Whoever is interested in this particular class will be available and listening to me. If I am only speaking to Amit or like Utkarsh, whoever it is, only speaking to only two of them or only one of them, that is a unicast communication. Okay. Hope you got to know the difference between unicast, broadcast, and multicast. Right? These are the three different types of communication we have in network. Hope that is all clear with you. Okay.
Sir, I have a question.
Moving on.
Hello.
There was
Hello.
some problem with the hub. I told you they invented a hub. Yeah.
Someone wants to.
Yeah,
someone
Shankar,
wants to
go
ask
ahead.
some.
Yeah, Shankar.
Sir, we are hello. Hello.
Yeah, I can hear you. Go ahead.
We all receiving your communication. So why is it not a broadcast?
Because you are a group of people, right? You are a particular group. Not everybody in this world are receiving that information,
Okay.
right?
Okay.
So, for example, this hub has 10 ports. Okay. Imagine This hub has 10 ports. Okay. If one person sends the traffic and all other 9 receives it, that is known as broadcast. If one person sends the traffic and only particular ones who are interested receives the traffic, that is known as multicast. If one person sends the traffic and only one other port receives the traffic, it is known as unicast.
And is it correct to say in broadcast, other 9 people, they cannot send traffic back, but in multicast, they can send traffic back to that one person?
Nothing like that. Nothing like that. So it is all like, so if you have PC1 sending the traffic, PC2 is receiving. Of course, PC2 also can send the traffic. He can, use the IP address of PC1 and send the traffic, right?
That's unicast, right?
Unicast. That is unicast. One-to-one is always unicast. If one person or one computer talking to another computer, it is always unicast. Right? Next thing. Maybe if you're not clear, I'll just give another part of explanation. Imagine a hub. Okay. Let's take 8 ports. 8 ports in a hub. Right? You can connect from your computer, you connect a cable to one of the ports. And there is another computer connected here. There is another computer connected here. Another computer connected here. One more PC connected here. One more PC connected here. So you are the designer. You are the designer for this particular network. You have so many PCs connected. Now, you want to speak to from one, let me name this 1, 2, 3, 4, 5, 6, 7, 8. You want to speak from 1 to 8 to send out the information. Information goes to hub. Hub is a device. So we just spoke that hub is a device which will never care where you send out to whom you send out the information. Even if it is from 1 to 8 or 1 to 7, my job is to send out the same information received from port 1 to all other ports. Even if you want to send it to only 1 to 8 or 1 to 7 or 1 to 3, I don't care. My job, the way I am designed is, if I receive any information on any port, I will transfer that information, or I will flood that information on all other ports. So basically, according to the type of communication that I explained you a little earlier, what kind of communication a hub is doing? It is broadcasting. Exactly. It is broadcasting, right? Because it is receiving on one port and it is flooding it on all the other ports, right? Basically, the hub is doing a broadcast. Now, this became a problem as and when the computers were, going more and more and more. This became a problem because there were companies set up at that time also. Now, this PC connected here, these two PCs which were connected here belong to the accounts department, okay, in the organization, okay. These two PCs which were connected here, they belong to some other department. Let's say HR department. And here the PCs These two were operations. This is also for operations. Now 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now I wanted to send one of the operations file which belong to the operations, like see, we have to use this VLAN, or we have to use the security guidelines to get the circuit up, or whatever. Okay, these are the rules that we follow. These are the secrets of networking. Something you have to send it to the operations department. But the problem is, once you send out of this PC, all other PCs were getting this information. The HR department didn't want this information. Accounts department didn't want this information. But still they are getting it. Right? So this kind of a disadvantage. Now, at the same time, even if operations 3 sends out a message to operation 2, again it will go to everyone. So as you can see, the arrow marks inside the hub, you see a lot of traffic, right? So there is a congestion in traffic. There is a kind of congestion. There becomes a lot of traffic that the hub cannot handle because of its broadcast nature, right? And also one of the disadvantages, the hub broadcasts to every port. With this, what happens? The computer, even though he is not interested, a computer which is never interested in the traffic, should, will be forwarded with that particular traffic, which is not what we want. So as and when the computer started increasing, as and when the network started growing, now there was a big headache. They started thinking about some other device which can actually perform efficiently, not like hub, which can broadcast, right? So then they came up with an idea, and they came up with something known as a switch, which is even famous even today. Which is still famous even today, right? I think most of you guys know about switch. Okay, maybe the functioning you would not have known, but okay, Amit, you want to ask something?
Yes, sir. So usually we come across two terminologies. One is broadcasting, which is clear. You have already explained it. But sometimes people also use flooding. So are they both same, or there is a difference?
They are both the same, because flooding, in the sense, when you just think about the river which is flooding, it doesn't care, right? It doesn't care. It goes everywhere. The water goes everywhere. That is why we use the word called flooding.
Uh,
Similarly, go ahead.
yes, sir. Understood. Got it. Thank you.
Yeah. Similarly, a hub also, it doesn't care who is sending from whom to who. It just floods from everywhere to everywhere. Okay. And Unicast, I think you would have understood. Broadcast and flooding are the same. Multicast, I think, multicast traffic you should be clear by now, because see, most of us are using. See, for example, when you think about Netflix or Amazon Prime, so if you are a subscriber, only you get that particular episode or season or movie, whatever. If you're not subscribed, you will not get that. So Netflix is only sending the channels or seasons episodes to those who are subscribed. That's kind of a multicast. Okay.
Sir, broadcast and multicast is somewhat clear. However, unicast is creating a bit of dilemma there. A reason being, suppose there we cannot unicast if there are multiple devices connected on a hub, right?
We cannot.
Okay.
But the problem will be the behavior of a hub. That's it. But if you send the information from this computer will definitely receive it. Okay. Now,
Understood.
your question is, can we unicast from in a hub? Can we unicast? Yes. The hub will broadcast. The hub will send to all other ports. Okay, it will send here, it will send here, and it will send here. Now, this computer's IP address is 192.168.1.1. This is 192.168.1.2. Now, if I send from 192.168.1.1 to 1.2, the hub will broadcast it to all the ports, but this computer will say, hey, I am 1.2 and I will receive this information. Now, this computer will say, I am 1.4 and I don't need that information. I am 1.3, I don't need that information. Even though it receives that information, then it will discard the packet. Discard the packet in the sense, even the information that it has received, it will just throw it away. Okay. Whatever the information it gets, it will just throw it away. It will not use that information because it knows it is not correct. Okay.
Understood, sir. Thank you.
Yeah. The next thing we're up to is the switch. Now there came, they wanted to do some, okay, let's do something.
Sir, email can be an example of unicast.
Yeah, email. See, so if I send it to Shankar Das only, email Shankar Das, only your email in the two, that will become unicast. If I email you, Amit Verma, then Virender Singh, if I unicast only particular of them, that will be a multicast. But if I use the group known as CCNA batch, okay, and send it to hi all, it will be a broadcast where I'm sending to everyone.
Oh, thank you.
Yeah. All right. Moving on. Now, they invented something known as a switch, which is denoted in network terms with the two arrows. One is pointing towards the right, the other is pointing towards the left. Okay. That was known as a switch. Now, switch, if they invented switch, now you would have already known, okay, it will not behave like a switch. It will not behave like a hub. Because the disadvantage of hub was it forwarded the information on all the ports. That is, it was flooding the information. It was broadcasting the information, right? That is one of the major disadvantages of the hub. Now, what happens if the hub broadcasts? The computers who are even not interested in the traffic will be able to get that information and they have to deny it later, right? That was the problem with the hub. Now, what happens with the switch? Let's say I have a computer connected here. Let's say I have a computer connected here.
Just just want to add one comment on this. Can
Go
we
ahead.
say radio is a broadcast?
Definitely, yes. It can be a broadcast if you think about only one frequency, right? If everybody switches to that particular frequency, it is a broadcast.
And in same sense, then news channel and TV channels, they are broadcast as well.
Yes, they are broadcast.
Thanks.
Now, in switch, we have these three computers, these four computers connected. Now, at first, let's give a name. Let's not talk about the IP address so far. I mean, so quick. say he is A and he is B. He is E, he is F. I want to go from A to B. I want to send the information from A to B. Let's look at how the switch behaves. Once the information comes here from the computer to this port of the switch, switch has something known as, in its CPU or inside the switch, there is something known as MAC table. Okay, MAC table. At first, where there is no information sent from any PC to any PC, the MAC table will be empty. The table will be empty because switch learns or makes this table dynamic. What do you mean by dynamically? Means as and when the information flows through the switch, it will create this MAC table. Okay, that is why we call it as dynamic. Now, once the information from A comes to the switch, now switch will see A is sending it to B. Okay, now switch will broadcast the information for the first time. Only for the first time, switch will broadcast the information on all its ports for the first time. Why? Because the table inside the switch, MAC table, is empty. It does not have any information stored for where is B. Right? Now, once also gets this information, and in this information, it is asking, are you B? Is your name B? So E declines this packet. F discards this packet. Now B checks this information. Here it says, are you called B? The computer B will understand, okay, this packet is for me. And he will reply back saying that, yes, I am B. In this process, there are two things which has happened to say that the switch is an intelligent device. As soon as the information came from A on this port to B, switch recognizes that, okay, I am getting information from A and A is connected to port 1. Okay, because this is port 1. It knows. So if I am like, if you think, just imagine, I have 4 to 5 hands. Okay, 4, 5 hands. Okay, one of you guys, I mean, for example, Bilal, Amit, Abhishek, okay, Pawan, maybe you are holding one of my hands. Okay, once you send the information or once you shake my hand and say, pass it on to maybe some other guy, and you say your name, I will know that, okay, my right hand is now connected to Amit or Bilal, whatever. Okay. Similarly, the switch also has many ports. Only once the information comes into that port, it will know that, okay, A is connected to port 1 because A will send the information with the source address and the destination address. Right? So looking at the source address, it will come to know, okay, my port 1 is occupied by A. Once the B receives this information and sees this information where A is asking, are you B? Then it replies, yes, I am B. Then it will make sure it will write down the table. Okay, B is connected to port number 4. Okay. Next time A sends any information to B, after that, next time, then it will check its MAC table. Hey, A, okay, A is anyways port 1, I have that entry. It wants to go to B. B is on port 4. Okay, let me forward that information only on port 4 instead of broadcasting on every other port. That is the functioning of the switch. That is how the switch was designed. Okay? Any doubts?
No, so far, good.
So
Sir,
far,
the
good?
MAC table will be formed when the first time A is sending a signal to a B, right? So at that time, the B's IP address will be port address will be stored in the MAC table, and next time when any traffic will be sent, it will go to B only, right?
Exactly. So this is A. First time when A sends the information with the source address as A. For example, let's create a source address and destination address. Source is A, destination is B. Okay, B is connected here, C is connected here, D is connected. Okay, this is B. Now source address is A, destination is B. Packet comes here. Switch checks that my MAC table is empty because it is the first time. Okay, so I will broadcast this on every port asking who is B, who is B, who is B. B replies, I am B. Once the packet comes from A, looking at the source address, it will say port 1 is connected to A. Okay, and when B replies, see, I am B, it will say port 4 is connected to B. The next time the information comes in, another packet comes in. Next time, I want to go from A to B. It will say information comes here. Okay, source address is A on port 1. I've already had that entry. Now I want to go to B. It will also again check the MAC table. B is connected to port 4. I will send only to port 4. I will not broadcast to all other ports. I will not do that. Got it? Clear on that?
Yes.
Yeah,
Yes,
thanks.
sir.
Okay. So that's about the switch. The same thing that I've written here. Hubs are called layer 1 devices. Switches are called layer 2 devices. But switches are known as intelligent devices as they can forward the frames looking at the destination MAC address. As I just showed you, looking at the destination MAC address. Looking at the destination MAC address. What is the destination MAC address here? B. Looking at the destination MAC address, they can forward the information to particular port number. We cannot connect PCs to each other to form a LAN. Hence, switches were discovered to do that job. Now, you might be wondering what is called as a local area network. This is a local area network. Means a switch which has 3 to 4 PCs connected. This is called as a local area network. Right? Nothing. So these are the terminologies that we use in network. Local area network, wide area network, metropolitan area network, right? LAN, WAN, MAN, okay? These are the terminologies that we use. Also remember the terminologies that I used here. Broadcast, flooding, okay? Unicast, MAC table, okay? These are the terminologies. Yes, Amit?
Sir, there are managed switch and unmanaged switch. But we'll come to that later. Sir, this MAC table that you just mentioned here, this MAC table, the switch is called an intelligent device and hub is not, because switch can prepare this MAC table, and then depending on the MAC table, it operates afterwards. This MAC table, can this be configured by us, and can this be set on a switch?
Definitely, you can do that. So basically, switch learns something dynamically. Okay, the design, the way it is designed, is to make a switch learn dynamically. But if you go to the switch, okay, if you go to the switch, you say on port number 1, I should only have the MAC address AB. Then by mistake, if somebody connects the device PC having CD MAC address, then definitely the information which is coming in, it will not allow that information to come in, right? Whatever MAC address I have configured, only that particular PC I have to connect to port number 1. Okay, even if you configure, you have to make sure that you are connected only with that PC. Okay.
Yes, sir.
For
Got it.
example, Amit, let me give you a better example for that. Amit, you used to have labs, right? Computer labs in your
Yes, sir.
schools, right? So they allowed you only to connect from a particular point. Okay. From a particular point, only if you can sit, you can access that particular lab. You can't sit everywhere and access them, right? Because they would have configured your computer's MAC address there on that particular port. If you connect with any other laptop, it would not work, or if any other computer, it would not work. Okay, that's how it is. You can do it manually also, but think in this way. Okay, on the switch, there is a MAC table. On the MAC table, what it does, every particular computer. Now this is the computer on which I'm sharing my screen, right? This is the computer. I'm sharing my screen. On this computer, there is something known as NIC card, which is burned. Okay.
Yes, sir. Network interface card. It is burnt on all the devices.
Exactly. All the network devices will have this network interface card burnt on the system, on the PC, while designing this PC. And this NIC card will have the MAC address. Every NIC card will have the MAC address. AB, or yours might be BC. Somebody else will be EF, like that. So when I might connect my computer here, when my computer sends the information.
Your voice is breaking, sir.
My voice is breaking, guys?
It's clear to me.
It's all right
It's
to me.
clear.
Okay.
Clear to me.
All right. Shankar, let me know if that happens again and again to you. So if my computer sends an information, switch will come to know, okay, I am getting the information from the MAC address AB. How will he get to know? How will the switch get to know? Because while sending the information, along with the information, my computer sends additional information saying that the source address is AB and the destination address is EF. Along with the information, it is also sending who is the sender, who is the receiver. Right? That is where switch knows port number 1 is connected to AB. Now, as Amit said, I can go ahead and configure port number 2 with the particular MAC address only, port number 3 with the particular MAC address only. I can do. But imagine huge organizations where there are 70 switches, 60 switches. Do you think a person can go to every port of those 70 switches and configure MAC addresses? It will be a difficult job, right? That is why we allow the switches to learn the MAC address dynamically on its own, right? Since that will be a tedious task to the administrator to go to every port and configure a MAC address, we allow the switch to do that job. All right.
Sir, suppose we are connecting a component like we are sorry, I'm getting ahead of you.
Yeah.
Should I ask this question right now or should I wait for it?
What's the question, Amit?
Suppose there is DHCP servers that works and it usually works on a router, but we can configure a server for it as well. We can use another device to act as a DHCP, and we want to connect it to a network through a switch on a particular port. So
Okay.
in that case, can we just manipulate the MAC table?
Definitely.
And okay, got it,
Definitely.
sir. That will be all. I'm pretty sure that you will be explaining these things.
We will get into it.
Yes.
We will
The
get it.
only second question that I have regarding switch is the difference between the managed and unmanaged switch. Is it just the layer difference that they work on, or something else as well?
Oh, okay. Since I've explained the switches, let me explain the managed switches and unmanaged switches also. Okay. There is all the switches which work on layer 2. Okay. Just remember this. Okay. Hubs work on layer 1. Okay. L1 is for hub, L2 is for. I'll tell you what are the layers also while we move across. Now, this
As per
is.
the OSI layers, sir, sorry, sir. You're talking about the OSI layers.
Yes, yes.
Yes, brother.
Okay.
Yeah, as per the OSI layers, this is layer 2, switch is layer 2, hub is layer 1. Okay. This is a managed switch, right? This is an unmanaged. Okay. Now, what do you mean by unmanaged switches? You people, most of you don't know. I will give a switch to your house, like a Wi-Fi. Do you know Wi-Fi? Wi-Fi is nothing but your switch, come router, come everything. It has switch, router, Wi-Fi, firewall, everything all in one. That is why it is known as a Wi-Fi. Okay, it's kind of an access point where you don't have to connect cable to it. It is also combines of access point. So there are many features on that Wi-Fi. Now, is that your Wi-Fi is that your managed or unmanaged? It is unmanaged because there are some devices an internet service provider gives to a home usage. When they give to home usage, at home, people will not configure anything on that switch. They just plug in a cable to that and they start playing. So, unmanaged switch are plug and play. Just plug in and start using. Right? There, we don't have any necessity of getting into the switch and configuring. right? We
No
don't have to
setup or no configuration is required in unmanaged switch.
exactly. But in managed switch, we can get into the terminal. We can do the configuration. Whatever you want. You can do a VLAN configuration. We can, bifurcate the traffic. Whatever configuration you need, you can do that configuration. That is why it is known as managed switch, where we can manage. Here, we cannot manage it because it is already managed by someone. Somebody has put in the rules inside this and just given it to us. We cannot manage it. We just have to plug in a cable and start using. It is more of plug and play types. Okay.
I guess there are some Netgear unmanaged switches or devices which are used as a plug and play and a medium.
Exactly.
There are Netgear devices. Cisco also has managed and unmanaged. So having said that, the MAC table manipulation that we were talking about earlier, that can be done on a managed switch only, not on an unmanaged switch. Is that so?
Definitely. Only on
Got
the
it.
any kind of alteration, any kind of changes can only be done on managed switch, because managed switch allows you to get inside itself and configure things. But unmanaged switch, you cannot get into the switch itself, right? Because you are not given access to even change anything on the switch, right? So maybe we spoke some of the concepts which are like maybe ahead of someone. Don't worry about it. We'll get there. You just remember what I told you. Just keep a note of it. As and when we get there, I'll explain it to you again. Okay? Right. Those were the concepts that we covered for today. I don't want to bug you more. So I know it is a lot of concepts for people who actually don't know anything about networking. It is quite more topics that we covered. But let me know if anybody has any doubts. Do you guys have any doubts, or are you good till here, or do you want me to slow down the explanation? Any feedbacks from you guys?
So far I'm good. This is
Awesome.
Neighbor.
Thank you, Virendra. Hope
Are you
everyone is good.
going to send any documents once we finish these lectures?
Yes, I will be. I will be sending you the PPT which I'm having, which is in front of me right now. So I'll be sending you the PPT, and also not only the PPT, we'll also do the labs and all that. I have the labs which are here.
According to the topic which we have
Yeah,
done.
according to yeah, that's right. We have the
All right.
labs next to the topic. So it is not like lab separate and theory separate. As and when we do the theory, I want to finish off with the lab then and there itself, so that you remember the concepts.
Thanks, many thanks.
All right. Thank you so much for joining, guys. Thank you so much for your time. So,
Hey Rahul, sorry to interrupt you here. Till now, you have covered two topics, as I can see, hubs and switches, right?
yep.
Okay. So now class will start at the same time, 9 a.m. from tomorrow.
Yes, that's right.
Okay. Thank you.
So tomorrow onwards, I'll try being a little faster. Maybe not faster in the sense, if you guys understand, I'll try to go a bit, so that you can also, finish your certification faster. Let's try. If not, if you're not understanding, let's keep it slow. Right then, let's wind it up for today, just because it is first day of class. Let's wind it up today. We can continue from today.
Thank you, sir. Sir, I just wanted to know if you are going to help us with the packet tracer and tools like that, so that we could,
I'm actually using